This instructional video covers the basics of real-time smoothness data analysis using FHWA's ProVal, Profile Viewer, and Analyzer software. There are two systems for assessing smoothness in real time during concrete paving operations: the Ames Real-Time Profiler and Gomaco Smoothness Indicator. Under the second Strategic Highway Research Program, SHARP 2, researchers evaluated and tested both technologies, improving process control and allowing on-the-fly equipment and operations adjustments to correct surface irregularities on concrete pavements during construction reduces the need to grind the final hardened surface to achieve smoothness requirements. Each system records data in a unique file format. Data collected and saved using the paver-mounted equipment can be copied onto a USB memory stick and imported into ProVal. ProVal can be used to convert the raw data to the ProVal standard file type for in-depth analysis. ProVal can help analyze pavement profiles quickly and provide results using several methods, including International Roughness Index, Ride Number, Profile Index, Rolling Straightedge, and many more. The following demonstration of the ProVal software uses data imported from the two real-time systems.
The first thing I'm going to need to do is create a new project. Then I'm going to go up to the top and click Add Files, and this is where I'm going to load the profile data files from that flash drive into the ProVal software.
Both systems use a combination of height, slope, and distance data to calculate the smoothness in real time. Either profile data file type can be imported into ProVal.
In this viewer screen, we can check these boxes, and this is just a basic view of that profile data. So we can see, again, this is an elevation versus distance plot. It's the profile. That's basically what the shape of the pavement surface looks like as it came out of the back of the paver. But you can see some general trends in the data over these two traces. These are from the left lane and the right lane.
To analyze the ride quality from the profile data, select the red car icon from the drop-down menu. Choose from IRI, HRI, MRI, or RN to select the type of ride quality analysis profile data to view.
There's several ways we can analyze the data under the analysis type. We can look at it overall. This will compute an IRI value for the entire section, entire length of that profile data. We can look at it based on a fixed interval report, which is essentially breaking the file into smaller segments and reporting one number for each. Or we can look at it with a continuous roughness report.
A user would typically start with a fixed interval report, as most agency ride quality specifications are written based on fixed intervals. 1/10 of a mile, or a 528-foot segment, is commonly used by highway agencies for ride quality specifications.
We'll select our two profile traces here, again, one from the left side of the paver, one from the right side, and we'll click the Analyze button.
The fixed interval report shows the IRI value for each 1/10 of a mile segment.
For the Profile 1 on the left side and the Profile 2 on the right side, so you can see the IRI numbers there. Higher than what we would typically see for a construction acceptance specification, but again, keep in mind the real-time data is generally always going to be higher than what we'd get from the final hardened profile.
The continuous roughness report indicates hot spots and shows issues with the profile data that may have been caused by processes in the paving operation. Selecting a higher threshold provides a localized roughness report.
So this is what we might call a localized roughness report. So it's identifying areas in the profile data where we had maybe higher areas of roughness. So you can see parts, especially the yellow trace for the left side of the paver, we had several areas where it stuck up above that threshold there. So a little bit rougher in those areas for that localized roughness. The right side, the blue side, not so much. So if I were a contractor looking at this data, I would maybe go back to my notes and see, did something change or something happen in the profile data or something happen in the paving process when I got to these areas here. and see if maybe there was maybe a change in the mix or a change in how the paver was operated that resulted in a little bit of localized roughness. We commonly see paver stops show up in localized roughness, so if the paver stops for any reason to wait on concrete or for any other reason, usually those will show up as a bump or a localized roughness in this profile data.
These IRI values are not the final hardened concrete IRI values. These values are just the numbers from the real-time system immediately behind the paver before any finishing, texturing, sawing, and sealing operations.
There's a lot that happens to the pavement surface after this data is collected. So in general, we see these real-time numbers are higher than what we'll get from the final hardened profile.
The Power Spectral Density tool helps identify repeating patterns in wavelength or frequency of the profile data.
And what we look for in this plot, on the bottom on the x-axis you see wavelength. Basically that means how often a certain feature is repeating, how many feet it's repeating. And so we see on the right-hand side of the plot, the longer wavelength content. So that would be the bigger changes in elevation, maybe grade is picked up in here, changes in grade. On the left side, we see the shorter wavelength content, so that's the really short, choppy stuff in the profile that a lot of times the finishers will actually take that out. And then what we're looking for is peaks on this plot to see if there's anything that's repeating in that profile data. And when we look for those peaks, sometimes it's easier to uncheck that log scale and look for these peaks. Sometimes we also need to apply a high-pass filter to get rid of some of the longer wavelength content. Really, the content that's most important to ride quality is basically between 3 and 100 feet is what we're primarily looking at. So I'm going to apply a high-pass filter to get rid of the longer wavelength content to make this a little bit easier to look at. And now I can start to see some of these peaks here. Again, this one's 95 foot. It's probably not terribly relevant to IRI. But we see a peak here right around 15 feet. And I know on this particular project we had dowel baskets every 15 feet. So my guess is that content here that we're seeing at 15 feet is related to the joint spacing or the dowel baskets. But again, the main point is this Power Spectral Density tool allows us to identify repeating patterns in the profile data, so that the next day when we go to pave, we can see if there's anything we can do to help mitigate that or reduce the effects of those repeating patterns. And profile allows us to dig a little bit deeper and try to do some investigation of that data. And if we do that at the end of the day, the next day when we start up to pave again, we can see if there's anything we want to change. Maybe in this case we would check the string lines to make sure they're tight, to make sure that 25-foot feature we saw in there was not, we wouldn't see that the next day of paving. You can see those types of things while you're paving. So if there was any kind of change in your paving process, maybe your mix changed a little bit, maybe added some water, took out some water, or changed some part of your mix, you can start to see that potentially reflected in that profile data.
Real-time smoothness systems are used by paving contractors for purposes of quality control and ensuring they have a uniform and consistent process.
The contractors that we see using these systems, they don't obsess over the numbers. They're using it as sort of a smell check while they're paving. They'll come by and glance at the screen. Nobody's standing there staring at the screen the whole time. They'll come by and glance at the screen and see, or maybe if they did make some change, like I said, if they change sensitivities or they change vibration or change the mix at all, they would make note of that. And all the real-time systems allow you to put an event marker in the profile data as you're collecting it. So you could put an event marker in there and say, at this station, we changed the mix. And at the end of the day, when you go back and look at your profile data, you can see what effect did that have on the profile and what effect did it have on my smoothness numbers.
For more information about real-time smoothness profile data, or to download a free copy of the ProVal software, visit our website at fhwa.dot.gov/pavement.